Welcome to the deep dive. You've been doing some really neat stuff lately, drawing those arcs and arrows in code and even getting a handle on local variables.
Yeah, getting those basics down.
Totally. Today, we're going to look at a way to level up those creative coding projects, something called for loops. Think of this as your shortcut to drawing multiple things. Maybe even making those arrows fly in formation.
Oh, definitely. It's a huge time saver.
We'll be diving deep into how these for loops work, especially when you're making cool visuals like circles and stars, and how the variables inside these loops can give you a ton of control. Our sources today are mostly learning materials focused on these core programming ideas.
Exactly. You've already experienced the power of telling the computer to draw one arc, one arrow. Now imagine telling it to draw a whole series, a pattern, without having to write the code for each individual one.
Right.
That's the superpower that loops give you. And the learning materials we're looking at today are perfect for understanding these fundamental building blocks.
Okay, let's unpack this. One of the first things we see is looping with this thing called range. So you might come across something like for I in range 10. What's the big idea there?
Well, the for keyword is your signal that you're about to create a loop, a set of instructions that will repeat.
Okay.
And range 10 is like saying, hey, I want to repeat this process 10 times. Each individual repetition is often called a pass. So in this case, the code inside this loop will run 10 passes.
10 passes, okay.
So you see that little I in there? For I in range 10?
Yeah, the I.
That's what we call the looping variable. Think of it as a counter that keeps track of which pass we're currently on.
A looping variable.
Right.
Okay, so what does that I actually do each time the loop runs those 10 times?
Here's where it gets really interesting. On each pass through the loop, the value of I automatically changes. The very first time the code inside the loop runs, I will have the value 0.
0, right.
The second time, it will be 1, then 2, and so on, all the way up to 9. So with range 10, you get 10 repetitions, and your looping variable I takes on each whole number value from 0 up to, but not including 10.
Got it. So I is like a little number that starts at 0 and automatically goes up by 1 each time the loop does its thing. The source gives a cool example where they draw 10 circles using the code circle, 40, I, 220. Can you explain how that little I changes where those circles end up on the screen?
Absolutely. Remember when you were drawing your arcs and arrows, you were giving the code specific coordinates, right? X and Y?
Yeah, exactly.
It's the same with circle. It needs an X coordinate, a Y coordinate, and a radius. In this example, the Y coordinate 200 and the radius 20 stay the same for all 10 circles. But take a look at the X coordinate. It's 40I.
40I. Okay.
So on the very first pass, when I is 0, the X coordinate is 40, which is 0.
Right, 0.
That's why the first circle center is right at the left edge of the screen at the X coordinate 0 and the Y coordinate 200.
I see. And as it becomes 1, the X coordinate becomes 40, 1 equals 40, so the next circle is a little to the right at 4,200. Then when I is 2, it's at 8,200 and so on. That's how they get nicely spaced out horizontally.
Exactly. It automatically calculates that new position on each pass.
But the material also mentions that the very first circle sometimes gets cut off a bit on the left. How did they fix that?
Yeah, that can happen if the radius makes it spill over the edge. They made a simple but clever adjustment to the X coordinate calculation. Instead of just 40I, they changed it to 20 plus 40I.
20 plus 40I.
So now when I is 0, the X coordinate is 20 plus 40I, which equals 20.
Ah, okay.
This effectively shifts all the circles a little bit to the right, just enough so the edge of that first circle doesn't get clipped, making sure that the first one is fully visible on the canvas. It's a small change, but it makes a big difference visually.
Simple but effective.
Yeah.
Now here's a quick question from the source. What do you think would happen if you used range 5 instead of range 10 in that first example?
Well, if range 10 tells the loop to run 10 times.
Then range 5 would run 5 times.
Exactly. It'll just run 5 times. And since the code inside the loop draws 1 circle each time, you would end up with exactly 5 circles.
Makes sense.
And given how the X coordinates are calculated, 20 plus 40I, these 5 circles would be clustered on the left side of where the original 10 were. You'd only see the first half, basically.
Okay, that makes perfect sense. 1 circle for each pass of the loop. But what if you want to do more than just draw a circle each time? What if you wanted to, say, draw a circle and also label it?
Good question.
The source talks about having multiple lines of code inside the loop. How does that work?
That's a really important concept. The body of the loop refers to all the lines of code that are indented underneath the for line.
The indented part, okay.
Right. Think of this indented block as a mini program that the for loop executes repeatedly. You can have as many lines of indented code as you need, and all of them will be executed in order during each pass of the loop.
And the example they give shows drawing the circles like before. Circle 20 plus 40i, 220, but then they add another line indented below. Label I, 20 plus 40i, 200, fill yellow, size 20. So on each of those 10 passes, it draws a circle, and then it draws a little label right on top of it.
Precisely, step by step for each pass. And notice something really clever about that label. The first thing inside the parentheses for the label is I, our looping variable.
Oh, right, that I again.
So the first time through the loop, when I is 0, it draws a circle and then puts the number 0 on it. The second time, when I is 1, it draws the next circle and puts the number 1 on it, and so on, all the way up to the last circle, which gets the label 9.
Ah, that's neat.
This really shows you how you can use that looping variable to control not just the position, but even the content or other properties of the shapes you're creating.
That's a really clear way to see it in action. And there's another question that pops up. If you used range 15 in that example with multiple lines drawing both the circle and the label, what would happen? The source hints that you might not see all 15. Why is that?
Right. Even though the loop would indeed run 15 times, diligently drawing 15 circles and 15 labels.
It's doing the work.
It is. But our screen, our canvas, has a limited size, The way the x-coordinate is being calculated, 20 plus 40i, means that as it gets larger, maybe past 9 or 10, depending on the canvas, with those circles and their labels start being drawn way off to the right.
Off the screen.
Exactly, outside of what you can actually see. So you'd have 15 sets of shapes being created behind the scenes, but you'd only be able to see the first 10 or so that actually fit within the visible area. It's a good reminder that the code is still running even if we don't see the immediate visual result.
Okay, so the loop is still doing its job, even if it's drawing things we can't see.
Yeah.
That's a good thing to keep in mind, especially when we're trying to debug our code later.
Definitely.
Now, the source also makes a point about the difference between code that's inside the loop, the indented part, and code that's around the loop, either before it starts or after it finishes. Why is that distinction so important?
That indentation is key. It's how Python knows what's part of the loop. Only the code that is indented directly underneath the for line is repeated for each pass of the loop.
Only the indented stuff gets repeated.
Correct. Any code that you write before the for statement, or any code that is no longer indented after the loop has finished all its repetitions, will run only once, either before the looping starts or after it is completed.
They have a simple example with labels that say, this is before the loop, and this is after the loop. And sure enough, those labels only show up on the screen once, while the stuff inside the loop happens multiple times. It really emphasizes what's being repeated and what's not.
It's a visual demonstration of the flow.
And the source also reminds us why range 10 gives us those I values from 0 to 9. It's because range n always goes up to, but not including the number n.
That not including part is crucial.
Yeah. And since our counter I starts at 0, the 10th time through the loop, I will have the value 9. It's a little detail, but it's crucial for understanding how many times your loop actually runs and what the value of your looping variable will be on that last pass.
Exactly. It's all about that starting point of 0 and that exclusive upper limit in range. Now, the last part of our learning material shows how you can actually put these loops inside functions. How does that give us even more power and flexibility?
Well, we've already learned that functions are like reusable blocks of code.
Right?
So if you put a loop inside a function, it means that every time you tell your program to run that function, the loop inside it will also run, performing its whole set of repetitive actions.
Makes sense. So the loop runs whenever the function runs.
Exactly. The source has a neat example with the on-mouse press function, the one that runs when you click the mouse.
Oh.
The first one draws a straight vertical line wherever you click the mouse, line, mouse X, 75, mouse X, mouse Y, that runs once per click. But then within that same function, there's a for I in range 5.
Ah.
A loop.
Inside the mouse press function.
Yeah. And that loop draws 5 green circles stacked vertically below where you clicked.
Oh, okay. So one click triggers 5 circles being drawn.
Yep. What's really interesting there is how the looping variable II is used to control the vertical position of those circles. For each pass of the loop, 0 through 4, the e-coordinate of the circle is calculated as mouse Y plus 15i.
Mouse Y plus 15i, so they get progressively lower.
Exactly. The first circle, when I is 0, is drawing right at the same vertical level as your mouse click. Mousey Y plus 0. The next one, when I is 1, is 15 pixels below that, mouse Y plus 15. Then mousey Y plus 30, and so on. So with just one click, you get a whole little stack of circles thanks to the loop inside the function.
That's pretty cool. One action triggering multiple, slightly different results.
And the second on-mouse press example looks even cooler. It uses a loop to draw a series of nested stars. Can you explain how that loop works?
Yeah, that one's visually quite nice. In that example, the loop also runs 5 times every time you click the mouse using range, and on each pass, it creates a star shape right at the X and Y coordinates of your mouse click. Mouse X, mousey Y.
Okay, same location for all stars.
Right, all centered on the click. But the key difference is how the size of each star is determined. The radius of the star is calculated as 10 plus 10i.
10 plus 10i, so the size depends on I.
Precisely. The very first star drawn, when I is 0, will have a radius of 10 plus 1 arrow, which is 10. The next one, when I is 1, will have a radius of 10 plus 10, 1, which is 20. Then 30, then 40, then 50 for the last one when I is 4.
Ah, so each star is bigger than the last.
Exactly. This creates that really neat nested effect where each star is a little bit bigger than the one before it, all centered at your mouse click.
It's amazing how just changing that one little calculation
Yeah.
based on our looping variable, I can create such a visually different and interesting outcome.
It really shows the power of using that changing variable.
And the source asks a really insightful question here. What if you change the star's radius to just 10i instead of 10 plus 10i? What do you think would happen then?
Ooh, that's a fantastic thing to think about. If the radius were simply 10i, well, think about the very first pass of the loop.
When I is 0,
Right, when I is 0, the radius would be 100o, which is 0.
a radius of 0. Can you even draw that?
Not really. As you can imagine, trying to draw a star with a radius of 0 isn't going to give you much of a star. In many coding environments, this could even cause an error because you're trying to create something that doesn't really exist or has no size.
Okay.
Even if it didn't crash your program, you'd end up with either nothing or maybe a single tiny point on the first try, I0, then a radius 10 star, I1, then radius 20, and so on. The progression of sizes wouldn't be nearly as clear or as visually appealing as when you start with a base radius of 10 and add to it.
Yeah, that 10 plus part makes sure the first one is visible.
Exactly. It really highlights how important it is to think carefully about how you're using that looping variable in your calculations, especially watching out for things like 0 values where they might cause problems.
Absolutely. So to bring it all together, it sounds like these for loops are a super useful and fundamental tool in programming. They let you repeat blocks of code as many times as you need without having to type it all out over and over again.
A huge efficiency gain.
Totally. The range function is how you control exactly how many times that repetition happens. And the looping variable that I usually acts like a counter that you can use to change different characteristics of the things you're creating, like their position, their size, or even what text they display.
Yep, you can use in all sorts of calculations inside the loop.
And you can even put these loops inside functions to make your programs more interactive and do more complex things when you trigger those functions, like with a mouse click, as we saw.
Precisely. You've seen how for loops can take a single instruction, like draw a circle or draw a star, and multiply its effect, allowing you to easily create patterns, sequences, maybe even simple animations down the line.
Right.
And by cleverly using the looping variable, you can introduce a lot of variation and complexity into your creations in a really elegant and efficient way. It's much better than copying and pasting code.
Definitely avoids that. So now that you have a better understanding of how loops and variables work together to draw shapes, think about those cool arcs and arrows you've been working on.
Yeah, connect it back.
Can you imagine other ways you could use loops to create even more intricate visual patterns? Or perhaps even make those arrows move across the screen in a coordinated way?
Ooh, animation.
Yeah, maybe you could use a loop to draw a series of increasingly larger arcs, creating a kind of spiraling effect, or have multiple arrows fanning out from a single point just by changing the angle slightly based on I.
Lots of possibilities.
This is really just the beginning, and these fundamental concepts, loops, variables, functions, they can be combined in countless creative ways to bring your coding ideas to life. Hopefully this deep dive has given you a clearer picture of how for loops work and how you can start experimenting with them in your own Python projects.